The topic which Hi students, the topic which you are going to see is law of conservation of momentum. We are going to see a problem in law of conservation of momentum. In the last video, we had the introduction about this topic. Here we'll be using two formulas, that is law of conservation of momentum, that is total momentum before impact is always going to be equal to total momentum after impact. You know the formula for momentum, that is mass into velocity. So as the law says, the total momentum before impact is going to be equal to total momentum after impact. So u1 and u2 be the total momentum before impact, and after the impact is happening, it is going to change as v1 and v2. Same mass, the mass is not going to change even after collision, so the mass is going to be the same. So the formula is m1 u1 plus m2 v2. Before impact, mass into velocity, momentum, and after impact, mass into velocity. After impact, the velocity will be v, that is m1 v1 plus m2 v2. We'll be using another formula, that is Newton's law of collision, that is v2 minus v1 is equal to e is coefficient of restitution into u1 minus u2, that is before impact. So let us start a problem. The problem is going to be very easy. Only these two formulas will be using. Two bodies, one of mass 30 kg, moves with a velocity of 9 meter per second, strikes on another body of mass 15 kg per second. 15 kg moving in the opposite direction with the velocity of 9 meters. Actually, this is supposed to be 15 kg not per second. Moving in the opposite direction with the velocity of 9 meter per second centrally, full stop. Find the velocity of each body after impact if the coefficient of restitution is 0.8. So these are the given data, m1 and m2, two masses, so two bodies of mass 30 kg and another is 15 kg, moves with a velocity of 9 meter per second, strikes on another body of mass 15 kg moving in the opposite direction. So this is moving in opposite direction, so we take minus 9 meter per second. E is coefficient of restitution, that is given as 0.8, and we are supposed to find what is the velocity after the impact. So as I told you, we'll be using only two formulas. And once again I'll explain the diagram. So one body is moving towards right, whereas another body is moving in opposite direction, so we are taking it as minus 9 meter per second. So this is the diagram. So we have to find what is the velocity after the impact. So initially we are using law of conservation of momentum, that is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That is using all these, we know we don't know the value of v1 and v2, let it be the unknown, and then so this will be the equation number 1. And now we are going to use Newton's law of collision. Then we will be using Newton's law of collision, that is v2 minus v1, that is velocity after impact is equal to E into u1 minus u2, that is velocity before impact. If you are substituting all the value, you know the value of u1 and u2 as well as you know the value of coefficient of restitution. Again you're going to get an equation as such. So equation 1 and equation 2, two unknowns v1 and v2. So by solving both the equations, you will find the value of v1 and v2, and that is how we solve the problem. For any problem that you are going to solve using this collision law of conservation of momentum, we will be using only these two formulas, that is law of conservation of momentum as well as Newton's law of collision. So by using these formula, you will be solving the problem. So in 4th unit you have like 3 important topics, as well as friction will be having. One is work energy, D. Albright's principle, and this law of conservation of momentum, that is collision, and another is friction. Thank you, students.